For a half cell, oxidation potential is negative of reduction potential. For example, zinc has got 0.41 volt as reduction potential minus. So oxidation potential will be 0.41 volt positive. This is reduction potential, this is oxidation potential. Negative negative will become positive. Everybody understands that? Oxidation will be minus, means negative of the reduction potential. Oxidation potential will be negative of the reduction potential. So how can we write it? Standard cell potential E naught equal to E naught reduction. Reduction happens on the right, and oxidation happens on the left. So whenever we write E naught right minus E naught left, E naught right minus, so both are representing the reduction potential. Both are representing the reduction potential. Either we write E naught oxidation plus E naught reduction, like here we have written. Look at this. E naught oxidation plus E naught reduction, or we write E naught reduction of the right half cell minus E naught reduction of the left half cell. Automatically it will come minus. Either write E naught reduction plus E naught oxidation as we have written over here, or you write like this. Both are, if you are taking both of them as reduction. Okay, you have to change simply the sign. That is potential arising due to the difference of potential of the half cell. Potential of the half cell will always be said as reduction potential. If you are talking about potential, it means automatically we are talking about reduction potential. If you are not talking about reduction potential, then you will have to specify that it is oxidation potential. Okay, you got this? So in general, let us say we have a reaction. If you still didn't understand, you will understand in 1-2 example. There is an oxidation reaction. So this will be representing as E naught oxidation. And how we represent? A to An positive. Let us say this is X volt. Let us say this is X volt. Now we reverse this reaction like this. So now it is reduction reaction. So the potential generated equal to E naught reduction. So how will write? Cation to atom. It will automatically become minus X volt according to the law of thermodynamics. Okay, you understood this? So all in all, for a half cell, E naught oxidation will always be equal to E naught reduction. Everybody understands that? Minus of E naught reduction. So E naught cell, that is standard cell potential, will be E naught cathode minus E naught anode. Cathode means reduction half and anode means oxidation half. But when we write E naught anode, it means we are talking about reduction potential. If we are not interested in writing anode, then write here oxidation and attach plus sign. For example, you are not writing it, I am erasing it. Okay, I have erased it. So what do we write here? We will attach the plus sign and we will write E naught oxidation. E naught oxidation. Or if you are not doing this, then what do you do? What you will do? You will write minus E naught anode. Cathode anode means we are talking about reduction only, reduction potential. That is E naught right minus E naught left. And if it is not a standard state, that is concentration not equal to 1 molar, then what do? We write ER minus EL, that E naught right, that is the reduction potential of cathode, minus EL, that is reduction potential of anode. Okay, or you write reduction potential of cathode plus oxidation potential of anode. You can write it. So now every time it is very difficult to draw the figure. You know, it's very big deal. You have to draw the figure, you have to show the solution, flow of current, you have to show the concentration, you have to show the cations, anion, anode, cathode, so many things. But there is a short way. What is the short way? Using the three components. Draw a double line. Double line means salt bridge. This is salt bridge. Let me write it over here. This is salt bridge. Okay, on the right of the salt bridge there was reduction half cell, that is cathode. Write the components of cathode. On the left side, write the component of anode. Write the component of anode, that is oxidation. Okay, this is the way. Anode. So if the components are in same phase, then we will use comma. We will use comma. Like this, ferrous to ferric, both are in aqueous, so we are using the comma over here. Okay, if the phases are different, then we will use a vertical line. For example, this is obviously solid. No, this is solid, so we will write solid over here, and this is aqueous, so we'll write aqueous over here, isn't it? So we have to show the vertical line. Okay, so along with the for example, we have to write the concentration or pressure. Okay, I'm just along with the components we have to write F again if we have to write concentration or pressure. How we will write it? We will say to it like this. For example, the concentration is 0.01 molar and the concentration of copper 2 positive ion is 0.01 molar. So how we will write it? We will show first of all initially it was zinc, it is converted into zinc 2 positive. We are using a straight line because both are in two different phases. We'll write the concentration on the right hand side, or you can write below over here. Then we will use the initial Cu2 positive. Initially it was Cu2 positive, it is getting reduced to copper atom. Straight line will show us that it is solid obviously, and Cu2 positive is aqueous and its concentration is 0.1 molar. So now it is oxidation, obviously it is anode, it is reduction, it is cathode. So this is the whole of the cell representation, battery representation. Okay, this complete is the battery representation, this one, Daniel cell. So Daniel cell means this one. The concentration can be different according to the question. We are taking the example of concentration, but this is the exact representation. We can write the pressure as well. Okay, if these are gaseous components, instead of concentration we will be writing partial pressure. So let us take an example. This is an example over here in front of us. A is losing 3 electrons going to A3 positive. Obviously this is oxidation half cell, concentration is 0.01 molar. This is gaining 2 electrons B and it is 0.01 molar. E naught, look at it, E naught, oxidation is happening for what? It is the correct value because over here oxidation is happening. Look at this, E naught, again oxidation is happening, but in the cell it is reduction. So we have to write the reduction value. Okay, we have to write the reduction value. How do we write the reduction value? B2 positive, it was initial, different phase B, and we are writing 1 volt. Everybody understands? Now it is raining outside, we will be taking in the next part, okay, about it.